Yeah, that's it. Vijay sir, please.
Yes. Good afternoon, one and all present here for 5 days online FTP program, Emerging Technology in Computer Science. It's my pleasure and a privilege to welcome our resource person, Mr. P. Vijay, Corporate Trainer, RJP Infotek Private Limited, Chennai. Today's topic is Data Center and Cloud COVID Impact. On behalf of Department of Computer Science Engineering, Dr.M.G.R Educational Research Institute, giving our warm welcome to our speaker and all the participants. Now, I would like to call our Professor Dr. Kanya, HOD, Department of Information Technology, to give the intro about our resource person, Mr. Vijay.
Good afternoon, everyone. It's my pleasure to introduce speaker of the session, Mr. P. Vijay, who is founder and lead corporate trainer at RJP Infotek Private Limited. Mr. Vijay is a professional with background ranging from IT infrastructure training to mentoring and managing a team, which reflect his varied capability. He completed his Bachelor's of Engineering in Electrical and Electronics Engineering from NIT Trichy in the year 1989. He is skilled enough in conducting need analysis, devising custom training programs. He is excelled in various technical skills and completed certifications in AWS Solution Architecture, Cisco certification like CCNA, CCNP, CCVP, Datacenter, MPLS, QoS, Multicast, NXX, VMware, and so on. He is also a certified system instructor earlier. Cisco certified trainer earlier. He started his career at MESC as service executive in the year 1989, immediately after completing his bachelor's degree. Then he moved to Accel Automation as a trained head in the year 1991. From the year 1993 to 1995, he served with his alma mater NIT Trichy as hardware engineer. After that, in the year 1995, he founded a company, RJP Infotek Private Limited, with a team of about 25 people. He is outside trainer in hardware and IT infrastructure for last 20 years to diverse client ranging from newly graduated individuals to experienced professional working in MNCs. His company client list includes Accenture, TCS, Severian Global, IOB, Volvo, R.R. Donnelley, BNY Mellon, FL Smith, Oracle, CSS Corp. The list extends. He has unique training pedagogy that focuses on simplifying technology combined with real-time skill development, imparting the best learning experience to participants is Mr. Vijay's specialty. His current interest includes translating the pedagogy into effective e-learning content. With this note, I welcome Mr. Vijay to deliver the session. Thank you, Mr. Vijay. Thank you, Vijay sir. You can start your presentation.
Yeah. Thank you, Professor Kanya, and thanks to the entire M.G.R team for having considered and invited me to this session. So the topic today is going to be on data center and cloud. The topic per se is not quite new. The topic per se is something that we are all familiar with. But the whole idea is we need to revisit this topic, understand its significance with the impact of COVID. COVID has changed many things. I don't think we would have ever met in this virtual world earlier. If there was a need, the dean would call me up, Vijay, why don't you come down? We have a discussion or we have something to consider. And I would just walk into your college. Probably this is the first time we are virtually meeting. And I'm quite sure no living human being has ever encountered this situation, because the last time the Spanish flu was over 100 years back during the World War times. And so there's been a huge impact of COVID. And in that light, we'll have to revisit and have a look at how the data center and the cloud infrastructure or the environment has impacted us. Okay, there could be one argument about COVID being a passing cloud. Well, yes, but then habits die hard. Once we have changed, we have got used to certain set of new habits, that's here to stay. I think you would have also read the news about IT companies as to how they are morphing into the new normal. TCS has already claimed that its target by year 2025 is to have 75% of the workforce working only from home. So the current strength of TCS is 4.5 lakhs. And it has already said that by 2025, we would target 75% of our workforce only to work from home. So how is that possible? So that's where the story is about. So since I'm told that there are a couple of hundreds of participants here, I don't want to assume too many things. I'm going to spend time on briefing the data center in terms of technology, briefing the variants of the data center, and give you a glimpse of the cloud as well. So the agenda is going to be like this. I'm going to start the story with the data center. And yes, as the first line says, we will see that it is essentially the data center that has evolved into the cloud. So the data center has undergone a lot of changes, and finally it becomes the cloud. It could be the private cloud, or it could even be the public cloud. So we'll see about that. I would not tend to go very elaborate on the topics because one, the timing, and the environment and the purpose. So I would go into discussing the advantages, understanding the environment, and to make you understand the environment in a more practical manner, I would take you through a small demonstration of a data center, which is a software-defined data center. I'll use VMware environment to show you a small demo. So that would help make things fall in perspective. Then we'll discuss the advantages, features of the software-defined data center. So that is when we start. I mean, that the moment I start talking that language, you would immediately able to relate how it is impacting in the COVID environment. So probably some of you would immediately be able to start guessing or start thinking as to what at M.G.R we could be doing to embrace these stuff. So that's my agenda, to make you think on how you can put things to use post this session. So once I'm done with the software-defined data center, we will move on to the cloud. Again, the new features. I'm quite sure you being from the Department of Computer Science, a lot of things would already be into your scheme of things, at least theoretically, academically. So what I would do is I would give you again a summary, taking the use case of AWS. Again, I would delve into giving you a short demo of the AWS environment, more to showcase how simple it is. Even though quite a few of you would have already tried it, the others would be motivated to get into and try the AWS if you want to after this session. So that is again going to be my agenda. I would then summarize it with some highlights, what the industry is talking today, what the news articles are carrying, what the business heads are speaking, some data some of you must have already come across, but that's just to summarize how things are changing for good. Right, then I'll open it for Q&A. I guess your format is that you would send across the questions and I'd be asked end of the session. So I'll keep the session timing as 1 hour, so that from now, so that we are able to finish this in time. I don't want to stretch too much and take away your evening. Okay, I have made some selection of pictures It might look too heavy for the afternoon, but don't worry. Don't pay too much attention to all the details. So this depicts a data center architecture. Some of you are from the Cisco background as well. You have a Cisco Academy. You might be involved in the activities. So this is a Cisco slide. So it shows a lot of network components. But let me simplify.
Sir, can you go for presentation mode, please? This is the first slide.
It's not showing up the second slide.
Yeah, it's showing only the first slide. Can you go for the presentation mode, please?
Let me just shift that.
Yeah, now it's going second slide.
Only now it's coming to this slide, is it?
Yeah, of course.
Is this moving forward?
No, it's in second slide right now. Yeah, yeah, that slide.
Okay, I think I'll have to change this. I'll just stop sharing for a moment. And is it visible full screen now?
Yeah, yes, sir.
Right.
Yeah,
Thank
please
you.
proceed. Yeah, thank you.
Yeah, so this is a picture depicting a traditional data center borrowed from one of the Cisco's pictures. I would like you to pay the attention only for the major areas. Any data center, as the name suggests, is a place where data is centrally stored, which is the reason why we are able to have anytime, anywhere banking, etc. So any data center would have three major components. The servers, which is responsible for computing all the data, processing all the data, so which we also refer to as compute. The network provides connectivity of all the servers. So the network provides connectivity to all the servers. And then the place where all the data is centrally stored is your SAN storage. So this constitutes the connectivity part, and it gets connected over WAN, wherein anyone from any remote location also would be able to connect and access all these stuff. So if I were to imagine the data center of any bank for that matter, let's say State Bank of India. So the State Bank of India would have a data center. I know one, it's in Mumbai, and they would have some other data centers as well. So this is what would be there inside. There would be a bunch of servers running all these softwares. And when we try to do an ATM transaction or an online transaction, everything goes and hits the Mumbai server. So the data is centrally stored. So irrespective of where we are going to access from, it is the centralized area from where the data is fetched. Okay. So the reason I call it a traditional data center is that there was no concept of what we today called as virtualization or software defined, etc. None of those existed. We had servers, the servers had installed server operating systems, and then the applications used to run in these servers. Even if it were databases, yes, the database would be installed on the servers directly on the hardware, much the way we work on our desktops or laptops today. So that is what I term it as a traditional data center. Okay. Now, what has happened to this traditional data center? Has it changed? Yes, it has morphed. It has evolved. What has been the evolution? What has been the improvement on this? The traditional data center, where everything was stored directly on the hardware, the compute, the server operating systems were running on the hardware, and all the data was centrally stored in the SAN, that changed. What did that change to? That changed to a virtual data center or a virtualized data center. Now, normally when I handle this session, I tend to ask a question, what is a virtualized data center? And many would return or come back saying that it is not real. Virtual means not real. in the literary sense. True, but that's not exactly what it means here. As you can see on to the right, we see all the devices that we saw in the traditional data center. You have the network components, you have the servers, you have the storage, only that the picture is differently organized, portrayed to also represent virtualization. So what we tend to mean here is that the hardware, whatever we see here, is virtualized. Now, many of you would have tried VM Player, VMware Workstation, VirtualBox, Virtual PC, so on and so forth. You run the software, virtualizing software on your desktop or laptop. You create virtual machines, and then you install multiple operating systems. So you're able to work with more machines than one, even though you have a single desktop OS. Okay, something similar happens here, only that the servers kept in a data center do not have any base operating system. They are installed with what are called as hypervisors, which directly virtualizes these servers. And on top of these servers, you start provisioning what are termed virtual machines, much similar to how you deploy on the virtual PC or VMware Workstation. You directly deploy virtual machines on the hypervisor installed or virtualized hardware servers. So what is the difference? The difference is like this. Earlier I had one rack server or one blade server running one operating system, and then it would run one or more applications. Now that is not the case. One hardware will run multiple server operating system. Maybe this is a Linux server, this is a Windows server, this is an Oracle database, all are running on the same hardware, independent of each other, as though they were three different hardware. So that is how in a data center, the virtualized server hosts multiple virtual machines. In a typical server, you will find something like 10 to 20 servers running in one hardware. That's how much of a capacity they have, right? So is that all? Does virtualization means that the compute is virtualized? No. As you can see, inside the hypervisor, you have a virtual switch. And it is this virtual switch that it connects or interconnects all the virtual machines between themselves and also provides connectivity to the physical switch. So network is virtualized, compute is also virtualized. What is not depicted here but is also virtualized is the storage. Each of these virtual machines do not directly store here. They store in a file which is the software equivalent of a hard disk, and that file, which is the software hard disk, gets stored here. Okay, so storage is also virtualized. So we managed to virtualize the compute, the network, and storage. So the entire data center components is virtualized. Why did we do that? Did we have any advantage? Well, yes, we had an obvious guess. You have more number of virtual machines in a single hardware, so that's a reduction of cost, reduction of power, reduction of space, all that is fine. Okay, but then something more also evolved. You started having the advantage of higher capacity utilization, because when this guy is running on peak performance, this guy may be running on low performance, this guy may be using medium resources. So on an average, what they would use is less than the entire capacity. So this allowed for over provisioning. When it allowed for over provisioning, that means even though the capacity is, let's say, there are 10 processors and 100 GB RAM, you could provision 20 processors and 200 GB RAM, knowing fully well that all put together at any given point of time would not consume more than what is available in the hardware. So what happens? Not only were the servers virtualized or all the parts virtualized, it also allowed us to create a much higher capacity. So these were tremendous advantages. The virtualized data center paved way for the next step. It was a change for good. We never go back to the original hardware-based data center at all. All the data centers that you would see today implemented would be a virtualized data center. Okay. The story did not stop there. Then came in your next evolution of the virtualized data center, that is a software-defined data center. And as the name suggests, this data center is more controlled by software. As you can see, there's a lot of confusion about this term, software-defined data center. What does the software-defined means? Is that the data center is created in software? No, not really. It is a software-controlled data center. You can look at it that way. Okay. So what is controlled in software? What is defined in software? A policy. We automate several things inside the virtualized data center based on a policy. Technically speaking, in an enterprise parlance, we call that SLA, service level agreement. So in the sense, let's say the bank has outsourced its data center to a data center provider. There's a huge data center provider, let's say Control S is a data center provider. And State Bank has said, hey, you take over. You provide me the data center facility and you're going to manage it. You're going to ensure that there is no downtime. You're going to ensure that my users do not complain of latency. If someone puts in the debit card into the ATM machine, within 1 second or 2 seconds, the screen should start showing the detail. Whatever he keys in, which part of the world he keys in, should be picked up, and the response time has to be only as fraction of seconds so that there is a smooth transaction and the user does not feel any delay. So what happens? The data center guys who provide for the solution must also ensure that irrespective of whether there are 100 simultaneous users or 1 lakh simultaneous users, the latency does not go beyond a certain level. So which means what? The computing power has to be powerful. Whenever the banking application is run, the performance level will have to peak. The application which is supporting the ATM machine must not have any latency. When it is fetching user data from the database must be highly available and it should be speedily accessible. So storage comes into play, compute comes into play, network connectivity comes into play. So what they would do? They would create a policy in software wherein they would adjust the resource allocated. If the resource allocated, network bandwidth allocated is less, which is causing latency, immediately increase the network bandwidth allocated to this ATM application. If the IOPS, IO operations per second for the database access warranted is more, because now there are 1 lakh users, so more amount of IOPS have to be dedicated, then increase the IOPS for that particular application alone. There may be umpteen number of stuff running in the data center, but when it is responding to an ATM, then this application must get an increased amount of IOPS written in software. So basically what they do, the caching handles that part. Right, compute. You'll have different hardwares running and different amount of resource allocated to different servers. So there could be one application server which is managing the mails. There could be the other application server which is managing your ATM boxes. So now this both need not be treated same. They need to have differential treatment. The one which is servicing the ATM will need to respond faster. So higher compute resource allocation in software to ensure a certain response time. So the policy will define the SLA as to what is the latency permitted, what is the delay permitted, and according to that policy, the resource allocation is dynamically managed in software. So when you manage the entire set of compute, network, storage in software thus, then the entire data center, I would say, is software controlled or software defined data center. So you have the policy based automation coming in. And today's virtualized data centers, they're no longer just virtualized data centers, they're all software defined data centers. So VMware, the world leader in this space, calls its product the software defined data center. Now this is where I would like to get a little technical. Let's have a look at some of the features that are software defined, where automation is involved, which is ensuring a certain degree of performance and uptime. For example, in your college, I'm not sure how it's organized. I'm sure, or rather I guess that you don't have a data center which is highly available, because I've not seen that in colleges. So I assume at the academia level, a highly available data center is not yet in place. So if you look at this picture, it gives you a glimpse of what are the automation features that a typical SDDC offers you. Let us look at this. I have 3 servers which are virtualized, and they are running several virtual machines. Assume one of the server fails or one of the hardware fails. You configure in VMware in software what is called as high availability to ensure there is an automatic failover. So the moment this goes down, the other 2 machines are going to take over the load. The machines that were virtual machines that were running on this hardware would restart automatically on the other hardware. Software control. Let's say this hardware is brought back up. Maybe it has got repaired, or it's replaced by a new hardware, whatever it is, you brought it back into the system. And now the virtual machines which had moved here and here have the new hardware available. You have a load balancing automation feature which is called distributed resource scheduler. The moment you enable this, what happens is the VMs which had gone here automatically come back into this. Not necessarily the same VMs, but VMs which are overloading these machines will automatically move to a lesser loaded or no load server. This is also automated. This is also software defined. In fact, the VMware administrator would configure these stuff. Right. When it comes to storage, we all know that whatever we store in a desktop or a laptop is stored locally in that hard disk. Okay. But what VMware did, it said, okay, in a data center, you're going to have a lot of hardware and a lot of hard disk, huge amount of space available. So what I would do in software, I would pull all the hard disks together and offer you the experience of a virtual shared storage, the vSAN. So which means today's data center need not purchase something separately called the SAN, which is pretty expensive. The local hard disks of the servers themselves can be configured virtually as a shared storage, and that is called the virtual SAN. Again, the whole stuff being done in software. So this is called the software defined storage. Right. So all these features, you can see that it is all part of the SDDC. You cannot emulate or simulate this in a regular environment. You have a server, okay, in an application level or in an operating system level, you can configure a cluster. You have multiple hardwares. One hardware fails, the other hardware will take over. But such a huge amount of features you can't have in a traditional setup. And suppose there are some critical applications running, like a banking application, or you have decided to run your exams online. You cannot afford a failure, you cannot afford a failover and then rebalance. For 10 minutes, there's a disconnection, not acceptable. So what happens? You enable a feature wherein those critical machines running the exam application are replicated and 2 copies are running simultaneously. VMware calls this feature fault tolerance. The meaning is one VM, which is a primary VM, is going to offer the load or take the load. Anything happens to this hardware and this guy crashes, the very next moment, there will be a very minute glitch that can be observed, if at all. Some may not even observe it. The secondary, which is also parallelly running and executing exactly like this machine, will go live. Or rather, this was always live. It was not connected to this network. It gets connected to the network moment this goes down. So ensuring that there is no downtime, no data loss, and no loss of connectivity as well. So the examinee, he would feel that the exam continues. There is no delay. He doesn't even know that there's a failure that has occurred in the background. So these are the advantages of a software-defined data center. And this is the reason. Now, as I tell you, as I give you the use case, you'll be imagining what all can be done. What are all the possibilities? And that is the relevance that we are talking about in today's COVID scenario. And not only things are changing in software, things are also changing in hardware. Okay. Earlier, you used to have the individual servers, etc., which were assembled, put together in a data center, and you had all that we spoke of, the virtualized software-defined stuff like that. But then some people in the hardware space also started thinking, why should we have software doing all the stuff? Why don't we integrate that as well? Why don't we put all the hardware together, integrate the software as part of the operating system or the hypervisor system, and offer what is called as a hyper-converged infrastructure? So this diagram is depicting that. I have the server, networking, and storage virtualized as well as controlled in software put in a single box. So if you buy this box, it will have literally 4 servers inside this, 4 motherboards, 4 set of hard disks, 4 set of process RAM, everything, 2 sets or 3 sets or 4 sets in a single casing. And whatever we spoke of in this slide is built into this box. So this is referred to as a hyper-converged infrastructure, wherein whatever was configurable there becomes a built-in feature. All you need to do is keep provisioning. You hardly get to know that something has gone bad because they would have already migrated with 0 downtime to all the other 3 servers or to the 4 node server. So the hardware has now become highly supportive of the SDDC. So one is beating the other. A lot of things are happening in hardware integration. A lot of things are also additionally happening in the software. So today's automated SDDC is offering you a lot more than what we have known. Right? So does it stop there? Not really. Because if I look at just the M.G.R. deemed university at Maduravoyal, okay, I have only one place, one university, all right. But then you also have other campuses. The chain of M.G.R. University campuses are more. You have a dental college elsewhere, you have another medical university elsewhere. Let's say you decide, or the management decides, to centralize everything and also have a redundant environment, because now it's not about one university, one college. I was in fact zapped when this morning I heard that the computer science department alone has got about 400 odd staff. I was zapped. I was thinking it's like a student crowd. So I can imagine your campus, the number of people there in total, plus the other campuses. It's going to be a massive number. So if we're going to centralize everything into a single place, then what if the data center fails? We being in Chennai last 5 years, we have seen enough. We have seen the Varda, we have seen the floods. I remember it very well because I was wondering when I was going to go down the water. The ground floor was filled and I was in the first floor. So if that being the case, and I also remember MGR was badly affected, so you would never want to have a single point of failure. That's how the data centers are designed. The criticality is so high that no single point of failure would ever be entertained. So be it at the individual hardware level, the individual hardware also will have everything in 2 numbers minimum. There'll be 2 networks, there'll be 2 storages, and everything will be a minimum number of 2. So something fails in the hardware, like we already saw, there would be a lot of servers. The virtual machines will fail over to the other place. Something fails in the storage should also have duplication. Something fails in the entire data center, you must have another data center where the entire set of data is replicated, and this goes up the moment this has some problem. So let's say one of your campuses got affected in the flood. The other campus is safe. So what you might do by design is have 2 data centers, one running in your bigger campus and the other as a backup. This guy continuously replicating or sending this information and making a copy in the other data center, other campus. Something happens here, flood or Varda or whatever, then within no time you bring this infrastructure up and this starts going live, productive. So a data center design ensures that there is no single point of failure, and the criticality will ensure how many data centers you have, what kind of a recovery you manage. In fact, in today's world, for people who don't have the second campus, or even though you have a second campus, you feel all said and done, all the campuses are in Chennai, then if Chennai gets affected, I do get affected. That is when a cloud comes in. So the cloud, the public cloud, I mean, like AWS or Azure or GCP or Ali Cloud or IBM or whatever, you will create your disaster recovery site on the cloud. Then you can choose where you want to create. You want to create in America data center, you want to create in a Sydney data center, whatever is seismically safe, whatever is seasonally safe, you want to ensure the best of both worlds. You can select a region and replicate onto the cloud. And all you do is pay only for that replication because you're not running anything. So if anything happens to the primary data center, that is when you kickstart the one on the cloud. That is when you really start paying more. So look at the criticality that is being addressed. You don't own anything, but you have the safety of a humongous environment in the cloud. So that's where we are today. So in fact, we don't talk just about SDDC, we speak about software-defined infrastructure, which means my software-defined data center has a hyper-converged infrastructure, all right, where everything is software-defined as we saw, and I add to it greater degree of automation and orchestration. What is not automated here, I automate here. And I can also write a workflow to sequence a set of events which is orchestrated and executed. So that is when the data center becomes a cloud. So to recall, whatever I said so long, we had the traditional data center with all the physical hardware components directly being used. That evolved into a virtualized data center wherein we use a hypervisor to virtualize the compute, virtualize the network, virtualize storage. We automated great many things in software wherein we got the software-defined data center. When we added a degree of automation to the hardware, we got the hyper-converged infrastructure. we add more amount of automation, not only about the infrastructure, but also about the software. We orchestrate a sequential set of events, tasks. Then what we have is a cloud. So the same data center which has the virtualized software defined infrastructure, which has got the virtual infrastructure, which has got a lot of automation done to an extent where I create a self-service portal. So what I say, I tell, hey, you're an administrator. You no longer have to go to a data center, create a VM, install an application, install a software, install a database, install application. All that you don't have to do. I have kept things ready in the background. I have written a workflow, and the workflow will be orchestrated by an orchestration tool. I'll give you a menu card, much similar to going to a restaurant. Go choose from that menu card what you want, and the orchestrator will orchestrate one task after the other. The automation will take care of each of the tasks. Orchestration
Oh, sir, it got stuck, I think. Vijay, sir? No audio from your side. Got stuck.
tasks together, minutes or few seconds.
Yeah, now I can hear you, sir. Now I can hear you.
Right, so can I continue then?
Yeah, please, sir.
So is the PowerPoint visible?
Yeah, that's coming, sir. Yeah, go ahead, sir.
So it's moving, right?
Yeah.
Okay, thank you. This is one problem. You start looking at the screen and start speaking. Assume that the other side is visible, and sometimes, yes, that's the flip side of technology also.
It's happened, sir.
Right, right. Okay, now coming back, I was mentioning that a highly automated, orchestrated, software-defined data center is what the cloud really is. If I'm going to use this for my own self, then I call it a private cloud. If I say my infrastructure is humongous, which is what basically Amazon did, it was selling books. It went on to sell books online, and then it said, why not extend this to others and other products? Then came in your AWS, Amazon.com, and then your AWS, and so on. So if I set up my infrastructure thus with a self-service portal, wherein I allow individuals to set up their own infrastructure, what I have is a public cloud. So AWS says, you want to create your account? Well, go ahead, create your account. I don't charge you anything for creating an account. Start using it. I'll give you 1 year free. Yes, there is a 1 year free tier. That's why I would encourage you guys to also try it out. Yes, you'll have to be careful, of course. So it says, launch whatever you want, use whatever you want. I'll bill you for whatever you use. You don't pay for what you create, like a hardware. You don't pay for a license separately, like buying a software. Nothing. You want to start working on some small project, mini project, student project today for the next 3 months. Use it for the 3 months. Cut it off, shut down your account, move on. I will not bill you anything more. So pay as you go. So that has become the public cloud and its advantage. In fact, I was taking the example of college, your college. But if you look at the Fortune 500 companies, the story is very, very different, in fact. Last time I attended an event more than a year ago, they were telling me that there's not a single top Fortune company which is working with a single cloud. None. All of them are working with multiple clouds. So which means they have their own data center. They might have just as a SDDC, or they might have converted it into a private cloud. They are connecting to the public cloud, which means in essence you have a combination of both. Any environment today is only a combination of both, the hybrid cloud. And it did not stop there. It is a multi-cloud. On-premises data center integrated with several other clouds. Why is it so? Simple. For all your Google Sheets, Google Forms, etc., I would prefer Google. But again, this meeting is also on Google Meet. But if I want to do some word processing and Excel sheet, etc., probably some of you may be using Google Sheet or Google Docs, but many would prefer MS Office or Office 365. I'd go with this cloud. And if I were to use Dropbox, or if I were to store some information, I might choose AWS. Each cloud has got its own unique value proposition. And when it is a massive infrastructure like that of a Fortune 500 company, Fortune 100 company, they will try to leverage the best of all. So they would have a humongous amount of subscription to each of these clouds. Everything would be integrated, and that would save them a lot of cost, and that would offer them high efficiency. So that is where we are today, right? So the cloud has the public cloud here, what I mean, has completely changed the way we have been working. We have been knowing hardware, buying license, installing, working, etc. The cloud has changed things completely. It has now become more like your, dish TV. Earlier, if I were to watch a high quality movie, I need to have DVD player, I need to have a home theater, I need to buy a Blu-ray disc. Every time spend 300-400 rupees on that disc, watch one movie. Today, I pay that 300-400 rupees to a service provider, be it Reliance or Airtel or Tata Sky or whatever. I watch hundreds of movies per month, OTT. Why? Because what was earlier perceived as infrastructure is today perceived as a service. That's exactly what these public cloud service providers got to us. Infrastructure you want, infrastructure as a service. You want a platform itself is offered as a service. Storage, service. Database, service. Functions, service. Software, service. And I would say this is one of the most interesting parts which you cannot imagine setting on your own, right? If you work with any of these, AWS, it's Lambda, I'm going to demonstrate that also. A function is available. Let me give you the straight takeaway. Python is part of any course today. I am quite sure you have that also as part of your syllabus. Let me assume that you're giving assignments to your students, and as a faculty, you correct it. The AWS Lambda is a function engine. You don't have to set up your infrastructure. You don't have to set up your Python platform, your C#, Java, Node.js, quite a bunch of softwares you don't have to install. You feed the code into it, it gives you the result. If the program doesn't run properly, it gives you the error. It throws up all the errors. You can just correct your students' code, or the students may use it for their project work or for their own use. They can use that, verify the issue, the corrections, execute it without any dependency. So that's serverless computing, which the public cloud has brought forth. And then the other most interesting thing that the public cloud has brought forth is microservices. I'm quite sure you would be more familiar with the Docker container, wherein each container does not run the entire operating system like a virtual machine, but it runs the relevant portion of the operating system which the application is dependent on. So if I were to run 3 or 4 programs or platforms or applications, I don't have to install the operating systems completely and run the applications. I can go for the container. They're all docked in the Docker, right? And I use the workflow which is available in my cloud to ensure execution of a series of tasks or programs. So that's how fantastic today's cloud is, public cloud. So you have the Docker container, which is your microservices. You have the Lambda, which is your serverless computing. You combine these two, use a built-in workflow and a lot of other components, you will be able to create fantastic stuff on the cloud at much lesser time with much lesser overall cost of ownership. If you were to build the same things yourself, it would be much costly. It would warrant a lot of technological expertise. All that is made redundant. But now you can't build this engine. He's done it in the background. So these are stuff which are not thinkable in the native cloud or native traditional data center or in your traditional server-based environments. And this is precisely the reason why we are hearing the term cloud native development. So we're going to leverage all the new advantages of what the cloud has got to offer. Your students can go on cloud, the faculty can go on cloud, the institutions can set up the data center. A lot many things can be done between this. So imagine the dependency. Now, LVC, Google Meet is one which is allowing you to interact with everyone else, all right. But what do you do about the platforms? What do you do about all the software, all the management, etc.? If your data center is in place at the college, you can set up whatever is cost effective in the data center. For whatever is of a higher value which you cannot set up in your environment, you think of the cloud, make use of the microservices, make use of the Lambda, you would be able to do fantastic things. So COVID is an eye-opener in all these respects. So the modern data center is the cloud. What was originally the traditional stuff has evolved and is today offering the service of a cloud. So what you cannot build in your own data center or your private cloud, you leverage the advantages with your AWS or Azure or whatever, whichever. All of these offer equivalent services. You may choose what works best for you, what features you need, what best pricing works, and leverage that. It can be done at an individual level, which I said. So just to give you a glimpse, so here is a picture depicting the AWS public cloud infrastructure, the global infrastructure. And as you can see, he's got data centers established in 24 parts of the world. Each region has got multiple data centers, which means about 76 plus data centers, which is called availability zones, because there will be one primary and one secondary minimum. There could be up to 6 data centers in each availability zone. And each of the data center having between 50 to 80,000 highly available servers. This is a glimpse for you to know how much AWS has invested. You go to Azure or something, I mean, you get an equivalent picture, but that's the size. So like I said, we are here and MGR has got one data center set up here, and you want the DR site, you can choose as far as US or Japan or Sydney or Africa or Bahrain or somewhere in Europe. Any place you can select as your backup. So that's the advantage of setting up the DR site on a cloud, right? So let me finish off with this balanced bit of theory, and then I can go for the short demos. This is a short or a small glimpse of the types of services which is available in the AWS computing platform. The core services constitute all your compute, storage, etc. The platform services include all the additional components which help you build a certain platform for you to execute your production environment. It also offers a marketplace along with its own software as a service for VDI and collaboration. There could be a lot of third-party services also, and cloud has been the biggest driver of startups for all the reasons that I said. Your students are interested in setting up something, they have an idea, they want to write a software, they know how to, they have the talent to write a software, but they don't have the infrastructure. This is the place. Zero investment, 1 year free. Of course, some services are charged, some are free. Most of the typically warranted are free. So they can set it up, they can do all that they want under the sun. So this is a real picture of the number of services. It's too dense, that's why I took a sample of this. So many services are available in the AWS, right? So that's about the environment. Right, so is that clear? I mean, can I go ahead with the demo process?
Yeah, please, sir.
Okay. So I'd like to go over to another screen where I want to show the demo of VMware first. Let me just invoke that, and then I'll share the screen. Please bear with me till then. So what I'm sharing with you now is something which VMware offers online, and that's free of cost. You can just create your own account, test it. Okay, the software defined data center. I'm going to choose, I hope that it allows, there have been a lot of changes. Yeah, it's allowing me to get in. So entire labs are pre-built, and we can use this to understand the subject. In fact, this is what we tend to use most of the times when we are trying to teach the online classes. So many a case we ask the candidates to log into the create an account in the VMware hands-on labs and say, hey, get into this lab and we will do a certain task today. I guess there are quite a number of users now, so it is taking some time. Okay, not bad. So hope my VMware portal screen is visible.
Yes, sir, you can proceed.
So I'm going to show you how a data center is managed in a VMware environment. So the management software is called vCenter. I'm logging into that. And here you can see that the vCenter is managing a data center. Okay. So let's assume that This is the data center of M.G.R. deemed university, right? And M.G.R. University has got multiple servers. So one is at Maduravoyal. So a bunch of servers are kept in Maduravoyal. Let me call it MVL cluster. Okay. And inside that cluster, you have two servers. These two components represent the servers. Okay. Now, what is the meaning of data center? What is the meaning of cluster? You have M.G.R. DU data center. You can have one more data center. Maybe I call it AC college. Another data center kept in that AC college. So that could also be managed by the same vCenter. So admin could be common, can manage multiple data centers. And inside the data center, you have some servers reserved for one department or one college, another bunch of servers reserved for another college or another department, so on and so forth. And what you see here, these are virtual machines which are running on these two servers. Now you can see the green arrow mark which says that the virtual machines are powered on. This is powered off. So let me try to just switch it on. This is a pre-built lab available in VMware's portal. I'm just making use of the same stuff. Now what is this cluster? Cluster groups these servers and offers me some of the features that we discussed earlier. I told you that there is a load balancing feature which is called the vSphere distributed resource scheduler. That is one feature. By default it is turned on. So I want to edit, I want to make some changes to the settings. I make it aggressive and I make it fully automatic. This is what is the configuration involved in the SDDC. Based on my preferences, I make a choice. So now what I've told this cluster, whatever servers are here, they should manage all these VMs. They should distribute all these three VMs equally among themselves. The load should be distributed. Then I go to the availability part, which means the failover gets enabled or disabled. By default, now in this case, it is disabled. I'm just going to get in and I'm going to enable the failover, which means vSphere HA is now active. I've turned it on. So now between these two servers, which are running these three VMs, if one of them fails, the VM which is running on that particular server would automatically restart on the other. And that is the demonstration I'm going to now do. So first, let's figure out which virtual machine is running on which server. So let me select one server and find out what VMs are running there. Both the Linux VMs seem to be running here. Linux VMs are small, so two VMs are running in this particular server. I move on to the second server and you can see that the Windows 10 is running here. It's not a dummy, it's a real VM. You can see that here. So it launches a console. You can see the Windows screen. So the Windows 10 is really running here, right? So let me keep this on. So to demonstrate how the automation works, what I'm going to do is this Windows is running on this machine, this server hardware. I'm going to shut this down. In other words, I'm going to simulate a failure. So what I do, I reboot. When I do that, you can observe that the server goes down. And when the server goes down, the Windows VM obviously cannot run here. It should automatically fail over to the second server, the one which is up and running. We'll have to give it some time because I've given a administrative reboot. It'll do a proper shutting down and restarting. So when it shuts down, the virtual machine will not have a server to run. So before it restarts, it will fail over to the second server. Let's observe that. You can see the alarm or the alert coming up, right? So the alert has come in here. So even though it shows there would be a failover time, you'll have to give it some gap. It's gone. And now when I come here, you can see that the Windows virtual machine has shifted. You can see that it's restarting, right? So basically when it crashes, it crashed, and then it restarts on the other available server. Okay. So this is a demonstration for failover. So the VM has failed over to a healthy server when the server on which it is running, the hardware on which it is running, has gone down. Now let me observe for some more time. I just made this to reboot. I have not shut it down. I gave a reboot command. So this is supposed to come back up. Let's give it some time. Let's see once it comes back up, what will happen is there would be high load on this server and zero load on this server. So what have I done? I've also enabled the other feature, DRS. So what does DRS automate? It will live migrate. This time it is not a failover, it is a live migration, mind you. It will live migrate any of this into this server automatically. I'm not doing anything, I'm just observing. You can see it was red, then it turned exclamation orange. Now this is normal, which means this has come back up. So once in a while, this cluster will do an analysis. Is the load equally shared? If the load is equally shared, it will not do anything. But if it figures out that this is overloaded and this is not loaded at all, then it will run the DRS. It will run
Every left.
Pardon?
Hi, sir, you carry on.
Right. So when the DRS runs, the load balancing will automatically happen. To save some time, let me try to manually do it. Otherwise, it is taking some time. I don't want to wait for that. So I'm just trying to simulate. Oh, it's gone. Right? And this is a live migration. This never went down. Console is disconnected, but yeah, when I click, you will see that it is not restarted. It is still on. Right? So there is zero downtime, automatic load balancing that happens. So this is a summary of the advantages that you get to have when you have a software defined data center. So the features of HADRS I've demonstrated now is the software defined data center features. So that's what I wanted to show as far as the data center goes. Okay. So now I'll spend a couple of minutes on the AWS screen. So let me unshare this and share the AWS screen. Okay, so this is my AWS console. I've already logged in to save some time. You can see the services. When I click on services, you can see the number of services that AWS has to offer. And they keep doing it all the time. They keep on increasing their services, fine tuning their services all the time. And you can see, I've chosen a region, London. It's left to me. Wherever I want to provision machines here, yeah, I choose this region, London. Right. And the first point where I start is that I need to have my own private cloud. The moment I log in, I see a service, I go to the virtual private cloud section. You can see something AWS has already created for me, and the entire setup is ready. So all I need to do is, if I want to provision a Linux machine, I'll walk you through how a Linux machine is provisioned. The virtual machine is not called a virtual machine, it is called Elastic Compute Cloud or a EC2 instance. I just go to the EC2 instance and launch an instance. So what I see is the self-service portal. Now you can see everything in action. I have a free tier checkbox, which I click here. I select Amazon Linux or Red Hat Linux. If your boys are doing Red Hat Linux program, they want to practice, ask them to do it here. I select one of the Linux machines. You can see that there is a free tier eligible machine available. All the others are charged. So you get to know that what is free and what is charged. Select the number of machines you want, and you don't have to do much. It's already there. All your network settings are there. Default, it'll have some storage. If you want to store something more, add to it, but please be wary of the free tier. Just go ahead, review, and launch. So it'll ask you to create for secure access what is called as a key pair. This has the public private key pair. Let me call it the key pair MGR. I will download this because this is what I will use to access this virtual machine. Once I'm done, because without this I cannot decrypt and the password will not work. I'll launch the instance. That's it. No virtual machine creation, no installation of operating system. It's all selection. I select the size, I select the operating system, and I say, hey, please deploy it for me in the private cloud that was present by default. So you can just wait, relax, and it'll be done. It'll be ready. 2 minutes. It'll perform some, once after installing, it'll perform some status checks. It'll say it's provisioned. Then all I need to do is, I need to find out how to connect that Linux machine. It is done via SSH, secure shell. When I use a secure shell, I will have to use this key that I downloaded. You click on connect, it will show you how that is done. So I'll borrow this. Please don't bother about what I'm doing. I want to simplify. So yes. Okay, this is how it is accessed. Okay. I'm going to just give the IP address. And going to I'm going to share my screen now because I'm going to go between different windows. Let me first copy the downloaded keypad. I hope you are able to see my command prompt.
Yes, sir. But the font is not visible.
A font is not visible, is it?
Yeah.
Is it visible now?
Yeah, go ahead, sir. No issues.
I'm now logged into the Linux machine. That's it. I provisioned right in front of you in the last 5 minutes. I provisioned the Linux machine in the Amazon cloud and I've logged in here. If you're able to see my screen, you can
Sir,
see
go
that.
ahead.
Right. So I've logged in. So this is a small demo of how easy it is to access. Right. Then the other small demo which I would like to show in AWS is I go to this Lambda function, which I was talking about. Okay. So I've already created a Lambda function. I've just copied some small, whatever available default hello codes because I didn't want to spend time. I'm not a coder. Okay. So all you need to do is, if the code is available, in this case, this is the code you can see here. Is my screen visible? The code is visible. It is a very small font, but is that visible?
Yes, sir. But can you zoom it out?
1 second.
Yeah, enough.
Right?
Enough, I think. Yeah, enough, I think, sir.
Right. So now you're able to see the code. I just some sample code. So when I want to run test, let's say that's the student code who has given it to you. You'll run the test and it is supposed to throw the results. And you can run the test here itself. And the results are shown here. Response value 1. So be it you wanting to use it for your own self, or you want the student to use, or you want to correct the student's code, it's fairly simple. You go to functions, you create a new function, you author from scratch, or you copy something which is existing in a blueprint, etc. And this is what I want to show you, what all it supports. You can choose between .NET, Go, Java, Node.js, Python, Ruby, etc. So all these are supported by this serverless computing Lambda. So that's basically the two demos which I wanted to show. One, how easy it is to operate, how easy it is to create something here, and two, how you can put it to use in your own environment. Right? So let me just go back to London. And the moment I'm done with my work, I simply select this terminate, job done. My billing stops. I would not even have paid 1 rupee for the time I have taken. It is quite affordable that way. Unless you're running 24/7 production for an individual level, it is quite affordable. Right, so coming back to just wind up. To make the last points, the data which I gathered in the last couple of days. So because of COVID, is my PowerPoint visible?
Yes, sir, you can proceed.
So because of COVID, what is the surge that these guys are experiencing? You can see that growing at 34%, AWS, Azure 59%, Google Cloud 52%. It is going phenomenally high. After COVID, of course, the growth rate might come down a little, but still the projection is like, cumulative. Hereafter, habits die hard. Once we got used to this system of things, a lot of things have migrated for good. They will not come back. If you're aware, Dropbox is on AWS. Netflix is on AWS. So you can imagine what is going to happen. And from the industry, what companies very much in India, what they are speaking. So from IBM, he says a lot of embracement has been going on in data, cloud, and AI. 3i Infotek has released a VPN service to enable people to work from home. Now TCS will only have to subscribe to this. Right? He has tied up with everyone. You can see all the names here. So Tech Mahindra is migrating a lot of client businesses into the IBM's cloud. Google Cloud is offering National Payment Corporations of India migration into cloud. Another AI company, Fluid. This is just, I was picking up this information just before this particular webinar. So a lot of things are migrating to cloud. A lot of dependencies are increasing to cloud. So between data center and cloud, a lot of things are happening. So it is highly important that all of us, embrace the technology and the direction in which the whole world is moving. So with that, I complete my presentation and I open it up for Q&A. I'm sorry I overshot by 10 minutes. I planned it to wind up by 4:15.
Yeah, no problem, sir. Next, we are having the questionnaire section. It will be led by Mrs. Aishwarya Devi, sir. Can you?
Yeah, please tell me.
Aishwarya Devi,
Thank you,
can
sir.
you please?
Yes, sir. Thank you, sir. Thanks for the wonderful session. Myself, Aishwarya Devi, Assistant Professor CSE. Here, some of the participants posted their questions, sir. Shall I read that first question?
Yeah, please go ahead.
Sir, can you elaborate how can VMware efficiently allocated in data center?
Okay, see, basically we're going to have this hardware virtualized.
Yes.
And as I was explaining, the virtualization has this advantage of optimal utilization of hardware, which means we're going to leverage on the averaging principle. One virtual machine is running on high load, the other virtual machine is running on reduced load, etc. So on an average, if I got a hardware of, let's say, 4 processors and 64 GB RAM, I would be able to provision VMs with 8 processors and 128 GB RAM, depending on what is the average utilization at any given point in time. So when it comes to leveraging the resources, it is over provisioning which helps. The other advantages are your failover, etc., which I demonstrated.
Thank you, sir. That's a second question. What are the benefit of hybrid cloud? Why should companies prefer hybrid cloud nowadays?
Okay, I'll give a simple example. AWS has got a service called CloudFront. This is nothing but a worldwide caching network. Whatever I showed you is where its data center resides. But then apart from this, it has got additional centers. In fact, Chennai would not be seen in that map, but Chennai has got a caching center.
Yes.
So similarly, it has set up caching centers across the world. Now, let me assume MGR's website is hosted in a particular server. And now you're getting global audience. You're going online, your university is offering courses to anyone across the globe, and then users in farthest part of the world are complaining of slowness. They're saying, no, I'm not able to listen to you. It is far too slow. So what you can do, you will hook up your server to AWS CloudFront. You don't have to subscribe to any other service of AWS. Just connect your server to AWS CloudFront. It will cache it to across the globe, and all the global users will find a much faster response. So now if you go to Azure, he may offer some other service which is cheaper, which is not offered by AWS. You may want to leverage that Azure service. When you want to talk of Google Sheet or Google Docs, you may want to leverage Google. So for different purposes, you may find different providers advantages. And that's the reason you go in for a hybrid cloud.
Thank you,
Your
sir.
premises has infrastructure plus additional features, you go to the cloud.
Okay, sir. The third question is, what are the advantages of AWS compared to OpenStack?
Okay, OpenStack, you're talking about the public cloud OpenStack or the other OpenStack which you're going to use to build. I'm assuming that you're going to build your own private cloud using OpenStack.
Okay,
See,
sir.
OpenStack will not offer you all the services that we spoke of. I gave you the example of Lambda. Doesn't exist.
Yes, sir. Yes, sir.
You only build the basic cloud infrastructure. If you want the advanced services, you have to go to those players who are offering those services. Microservices, serverless computing, so on and so forth. I have not briefed most of them. Something very important and very significant I briefed here.
Okay, sir. Okay, sir. The last question. What is the use of VMware in fault tolerance, and how many virtual CPUs can I use on a fault tolerant machine?
Okay, looks like this question is from someone who knows VMware. Okay, so VMware has a current maximum of 4 vCPUs per VM.
Okay.
Okay, you cannot cross 4 virtual CPUs. Earlier versions had only 1 virtual CPU for enabling the fault tolerance feature. The difference fault tolerance brings to the table is 0 downtime. HA will give you failover, but it will have a downtime. The virtual machine will restart. Whereas fault tolerance, there is no restart, it is 0 downtime.
Thank you, sir. Thank you so much, sir. Thank you, sir.
Thank you very much.
Thank you, Mr. Aishwarya, for the question session. Can I call upon Mrs. Amuda ma'am for the vote of thanks?
Good evening, everybody. Myself, Amuda, on behalf of Department of CSE, Dr.M.G.R. Educational Research and Institute, extend a very hearty thanks to our profound speaker for taking time for his respective schedules and share his valuable knowledge and this beautiful moment with all of us. I would like to take this opportunity to place on record our hearty thanks to all the participants. Stay tuned tomorrow by the same time. Link will be shared in Telegram group MGR CSE. Thank you.
Thank you, ma'am. Thanks, sir. Thanks for the valuable session, sir.
Thank you all. Thank you.
Thank you, sir. Thank you, sir.
Vijay sir.
Yes,
Vijay
ma'am.
sir, Geeta.
Yes, ma'am. How are you, ma'am?
சூப்பரா இருந்தது.
அப்படியா?
Fine. சூப்பரா இருந்தது. I'm traveling. அதனால தான் என்னால வந்து ஃபுல்லா செஷனுக்குள்ள வர முடியல.
Fine.
இனாகிரேட் பண்ண தினேஷ்